An electric motor spins the hard drive's disk at exactly 7,200 revolutions per minute. The circuit board keeps the speed constant. And here's the crucial part, the actuator arms that hold the read-write heads. The ends of the arms are split, and right in the middle ride the disk platters. But the heads never actually touch the disks. The space between the head and the surface of the disk is 5,000 times thinner than a human hair. The heads float on a cushion of air created by the spinning disks. An absolutely essential cushion that prevents the head from crashing on the disk. And what a crash it would be. Talking about a crash is not only a metaphor. At these tiny scales, the weight of the heads really compares to the weight of a 747 airplane. A 747 airplane packed with 100,000 passengers, flying at 60 miles per hour, 1/100th of an inch from the ground. Ouch. There's no friction to slow things down, so the arms can move the heads to write or access data up to 60 times per second. The engine that drives the arms is invisible because it's an electromagnetic system driven by two forces of nature, electricity and magnetism, which makes the arms move back and forth across the disk at lightning speed. That's it for the components. Now here comes the data. The data is stored inside tiny concentric tracks on the disk's surface. During manufacture, up to 200,000 of these tracks are created on the disk. Each track is divided into sectors. A map of the tracks and sectors in the printed circuit board tells the heads exactly where to read or write information. The surface of the disk is smooth and shiny, but look closer. It's way more complicated. A magnetic film on the surface memorizes all the information. The heads magnetize microscopic sections of the film and store the data in a sequence of ones or zeros. Each one or zero is called a bit. The value of each bit is determined by the orientation of its magnetic field, plus or minus. And it doesn't take long for the bits to add up. One high-quality photo can take up 29 million bits spread across 12 different sectors of the disk. This sounds incredibly massive, but in reality, a stupefying quantity of bits can fit in an extremely small space. Each square centimeter of the disk's surface holds 31 billion bits. Now that's space-saving. A hard disk stores and recovers a phenomenal amount of information at speeds that defy comprehension. Using the power of magnetism, the shiny surface of a hard disk can store the contents of several sets of encyclopedias, or hundreds of thousands of images. Easy. The hard disk really is an amazing, shrinking machine, squeezing mountains of data into little bytes with a single key stroke. This masterpiece of engineering has really stretched the boundaries of physics, bit by bit. Coming up.